Millions of people across the world live with disabling hearing and vision loss. The vast majority live in low and middle income countries where they often do not have access to appropriate hearing and vision care services. Without suitable interventions, hearing and vision loss pose a significant challenge in the lives of those affected. Currently, there are approximately 40,000 legally hearing impaired people living in Malaysia. And in 2016, with a total population of 28.33 million, Malaysia has an average of 1.2% prevalence of blindness.
Hearing loss entails a loss of auditory information which may affect behavior in traffic and might reduce traffic safety. There are several situations in which hearing could play an important role in road safety. One example that it is generally assumed that pedestrians are able to hear road sounds including alarms, whistles, sirens, traffic and also traffic control systems. Clearly, an inability to hear this audio information could increase the risk for road safety incidents to occur.
Visually impaired people have to face many challenges in their life as they are unable to see things around them, either partially or completely. The biggest challenge for a visually impaired person is to navigate around places. Globally, at least 2.2 billion people have a near or distance vision impairment. One of the consequences of vision loss is being uncomfortable about safety while moving around or traveling independently. When walking on the streets, visually impaired pedestrians will have difficulty identifying obstacles in front of them, which is extremely dangerous.
Pedestrian safety is an important issue. Crossing the street is an everyday task. However, it is a complex, difficult, and dangerous task that can be affected by many variables, such as the viewing and the auditory environment of the street, number of pedestrians crossing the street, and the previous street crossing experiences of the pedestrian. In Malaysia alone, pedestrian fatalities are averaging approximately more than 500 deaths each year.
Therefore, we have come up with a helpful solution, which is a bracelet-like device called iSensory. This electronic helping system is designed to solve such issues that may be faced by hearing impaired and visually impaired pedestrians. The system we have designed consists of sensing the surrounding using an ultrasonic sensor, which then alerts the user when there are any obstacle or threats near him via vibration. Besides, this device also has a sound sensor that measures the intensity of noise, music, and other sounds around him. When extremely high volume is detected, an LED will light up and alert the user.
Our research is to alert visually and hearing impaired pedestrians from dangers in their surroundings and also to reduce accidents by the roadside involving visually and hearing impaired people.
Here is the 3D digital illustration of the iSensory. It consists of an ultrasonic sensor that detects obstacles and a sound sensor that detects sound and noise intensity. There are two LED lights at the right and left side of the sensors, which will light up when a certain noise limit is exceeded. Next, there is a vibrator located at the bottom of the strap that will vibrate when threats are identified, and a power button at the side to switch on when needed.
Here are the measurements for iSensory. The case has a length of 50 mm, width of 25 mm, depth of 20 mm, whereas the strap has a length of 220 mm, width of 24 mm. The total weight is 30 grams. So, how does this device actually work? As you can see in this diagram, when the power button is switched on, the system will start functioning. The ultrasonic sensor will sense obstacles in the surrounding. We designed a device where it will vibrate faster when the obstacle is nearer to the user. Therefore, when it is in the range from 80 till 100 centimeters, the vibration rate is fast. If it is from 101 till 120 centimeters, the vibration rate is medium. And from 121 till 140, the vibration is lower. If the obstacle is further away than 140 centimeters, it will not vibrate. This obstacle detection system is mainly focused for the visually impaired since they cannot see what's around them.
Next, the sound sensor is used for detecting the surroundings noise level. When the noise level is below 60 decibel, the LED lights will not light up. Examples of noises below 60 decibel are whisper, light rain, and a quiet environment. If the sound decibel is from 60 to 79, the green LED will light up. Some examples are a normal conversation, background music, and the sound of a vacuum cleaner. However, when the noise level exceeds 80 decibel, the red LED lights will light up. Examples of them are heavy traffic, shouted conversation, and police car sirens. This is because sounds above 80 decibel are considered very loud and harmful for the ear. So, it will alert the hearing impaired user that the noise in their surroundings may be dangerous. For better visualization and understanding, here is a representation of our concept to show how it functions.
The approximate cost for this iSensory is 100 ringgit. From the aspect of market and commercial potential, our product is expected to be one of high-in-demand products among the hearing and visually impaired people. This is due to the increasing percentage of blindness and deafness prevalence in Malaysia and around the world in the upcoming years. In addition, our product has a reasonable price for those who can afford the expensive one. Therefore, iSensory will most likely last long in the market.
There are many benefits of our system, including ensuring user safety, especially in the public. Besides that, this iSensory also help increase users' alertness, and lastly, the system also can reduce the number of accidents involving visually and hearing impaired people. Furthermore, this product is affordable and user-friendly because it is convenient and easy to bring anywhere.
In summary, this obstacle detection system detects moving objects near the user and notify via vibrations. It also has a sound sensor that detects sound in the surrounding and alerts the user with an LED when a certain limit is exceeded. The prototype is user-friendly and cost-efficient. It is seen as an improvement in the field of device for the hearing and visually impaired, thanks to its durability, user-friendliness, and cost efficiency.